Course T216B CCNA 4 Connecting Networks Chapter number 5 Network Address Translation for IP version 4. In this chapter we are going to talk about NAT operation, how to configure NAT, how to troubleshoot the NAT, and we will end up the chapter with summary. The basic objectives of this chapter 5 are: what are the NAT characteristics, the benefits and drawbacks of network address translation, how to configure static NAT using the CLI, how to configure the dynamic NAT using the CLI, how to configure port address translation or PAT using the CLI, how to configure port forwarding using the CLI, and how to configure NAT64, and finally use the show commands to verify NAT operation. NAT operation. IP version 4 private address space is not big enough to uniquely address all the devices that must be connected to the internet. These network private addresses are described in request for comment document number 1918 and are designed to be used within an organization or site only. Private addresses are not routed by internet routers while public addresses are. Private addresses can alleviate IPv4's scarcity, but because they are not routed by the internet devices, they first need to be translated. Network address translation or NAT is a process which is used to perform such translation. IPv4 private address space. According to the request for comment document 1918, we have three different classes, namely class A with the internal address space range started from 10.0.0.0 to 10.255.255.t55. Class B range starts from 172.16.0.0 till 172.13.255.255, and class C starting ranges from 192.168.0.0 to 192.168.255.255. So the basic job of the NAT router is to translate the internal network, which is the private IP4 address space, into the public IPv4 address space. What is a NAT? NAT or network address translation is a process which is used to translate the network addresses. The primary use of the NAT is to conserve the public IPv4 addresses. NAT is usually implemented at the border network devices such as firewalls or routers. NAT allows the network to use private addresses internally, only translating to the public addresses when it is required. Network devices within the organization can be assigned private addresses, and they operate with locally unique addresses. But when the traffic must be sent or received to or from other organizations or through the internet, the border router translates these private addresses to a public addresses and a globally unique addresses. This diagram shows how the border router, which in this case router 2, translates the internal private address space of the network into a public address space. NAT uses different terminologies such as inside network, outside network. Inside network is the set of devices which are using the private addresses, and outside network refers to all other networks which is outside the organization. NAT includes four types of addresses. Number 1, inside local address. Number 2, inside global address. Number 3, outside local address. And number 4, outside global address. This diagram shows the NAT terminology. the source address and destination address. The source address is inside the organization, which is inside local, and destination address is outside local. So this is the responsibility of a border router, where NAT enables to convert these inside private IP address range into a outside public IP address range. The type of NATs. One of the type of NAT is a static NAT, which basically uses a one-to-one mapping of a local and global addresses. These mappings are configured by the network administrator and it remain constant. A static NAT is particularly useful when server hosted in the inside network and which must be accessible from the outside network. A network administrator can SSH to a server in the inside network by pointing the secure shell or SSH client to the proper inside global address. The diagram shows the static NAT table where one-to-one IP address mapping is done. The other type of NAT is a dynamic NAT, which basically dynamic NAT uses a pool of public addresses and assigns them on a first come first served basis. When an inside device requests access to an outside network, dynamic NAT assigns an available public IPv4 address from its pool, and dynamic NAT requires that enough public addresses are available to satisfy the total number of simultaneous user sessions. In this example, we can see the dynamic NAT is in operation and there is a dynamic NAT address pool is configured, which maps inside local addresses to inside global addresses. Another type of a NAT is a port address translation or PAT. Port address translation maps multiple private IPv4 addresses to a single public IPv4 address or a few addresses. PAT uses the pair source port and source IP address to keep track of what traffic belongs to what internal client. PAT is also known as NAT overload or network address translation overload. By also using the port number, PAT forwards the response packets to the correct internal device. The PAT process also validates that the incoming packets were requested, thus adding a degree of security to the session. Comparison between NAT and PAT. NAT translates IPv4 addresses on a one-on-one basis between private IPv4 address and a public IPv4 addresses. PAT modifies both the addresses and the port number. NAT forwards incoming packets to their inside destination by referring to the incoming source IPv4 address provided by the host on the public network. With PAT, there is generally only one or a very few publicly exposed IPv4 addresses. PAT is able to translate protocols that do not use port numbers such as ICMP. Each one of these protocols is supported differently by port address translation. Benefits of NAT. NAT conserves the legally registered addressing scheme. NAT increases the flexibility of connections to the public network. NAT provides consistency for internal network addressing schemes, and NAT also provides network security. Similar way, disadvantages of a NAT. Performance is degraded, end-to-end functionality is degraded, end-to-end IP traceability is lost, tunneling is more complicated, and initiating the TCP connections can be disrupted. Configuring NAT. Configuring a static NAT. There are two basic tasks to perform when we are configuring the static NAT translations. First, we need to create the mapping between the inside local and outside local addresses. Number two, we need to define which interfaces belongs to the inside network and which interfaces are belong to the outside network. In this example, we have inside network which is configured on serial 0/0/0 interface on router 2, and outside network is configured on serial 0/1/0 interface on router 2. We can configure the inside net by using the command ipnat inside source static, and we have to mention the IP address. In this example, we have a web server IP address which is 192.168.10.254, and this static NAT mapped to the outside client, which IP address is 209.165.200.254. And then we can configure interface serial 0/0/0, and then we have to giving the IP address on router 2 serial interface, and by giving the command ipnat inside and then properly exit. Analyzing the static NAT, as we can see in this example, the network address translation NAT service is configured on router 2, which basically maintains inside local address, inside global address, and outside global address. In order to verify the static NAT, the static translation is always present in the NAT table. So on the concerned router, we can simply give the command show IP NAT translations. And the static translation during an active session, we can give the command show IP NAT translation, which will give the complete information about inside global address, inside local address, outside local address, and outside global address. Further to that, if you would like to verify the static NAT, we can give the command show IP NAT statistics, which basically tell us how many connections are currently active. In this example, one static connection, and we can connect client PC, establish a session with the web server. In order to clear the statistics, we can simply use the command clear IP NAT statistics. Dynamic NAT operation. The pool of public IPv4 addresses inside global address pool is available to any device on the inside network on a first come, first served basis. With dynamic NAT, a single inside address is translated to a single outside address. The pool must be large enough to accommodate all inside devices. A device is unable to communicate to any external network if no addresses are available in the pool. Configuring the dynamic NAT. In order to configure the dynamic NAT, we have to follow different steps. In step number 1, we need to define a pool of global addresses to be used for translation. The command is ipnat pool, and then we have to give the name of the pool, start IP address and end IP address range, network mask, and prefix length. In step number 2, we need to configure a standard access list permitting the addresses that should be translated by using the command access.list, access-list, and access-list-number, and then permit, and we have to give the source and wildcard. In step number 3, we have to establish the dynamic source translation by specifying the access list and pool which is defined in the prior steps. At this layer, we have to give ipnat inside and then source list and then access list number and the pool name. Step number 4, we have to identify the inside interface by giving the command interface and then type number and ipnat inside. And in step number 5, we have to identify the outside interface by giving the command ipnat outside. This PowerPoint presentations shows the analyzing the dynamic NAT. Once dynamic NAT is configured, all the informations are available on a connected router interfaces, and all the informations are available in the routing table, inside global addresses list and inside local addresses pool, which is one-to-one mapping between inside local addresses to outside global addresses. In order to verify the dynamic NAT, we can give the command on a concerned router, in this example router number 2, show IP NAT translations, which basically shows what are the inside global addresses and what are inside local addresses. We can also use the command show IP NAT translation in verbose mode, which is show IP NAT translation verbose. We can also clear the data by using the clear IP NAT statistics command. And once the session established between PC1 and PC2, we can use the command show IP NAT statistics, which shows the dynamic connections and which also shows the pool. In this example, the name of the pool is that pool, and which shows the starting IP address and which is linked to the external IP address. Configuring PAT, port address translation address pool. First, we need to define a pool of public IPv4 addresses under the pool name, in this example nat-pool2. Then on router number 2, we have using the command IP space nat space pool nat-pool2, and then mention the IP address, which in this example is 209.165.200.226 to 200.9.165.200.240 and subnet mask 255.255.255.224. And then in the second step, we configure the access list and we permit the range of IP addresses. And then in the third step, we have given the IP NAT inside source list 1 pool, and then we have given the pool name, which is in this example nat-pool2 overload. And then we identify the interface, which is interface serial 0/0/0 as an inside NAT interface by giving the command on router 2 interface space serial 0/0/0 and IP NAT inside. Then we have to identify interface serial 0/1/0 as the outside NAT interface on router 2 by configuring the command interface space serial 0/1/0 IP NAT outside. This is how we have to configure the PAT on a router. If you would like to configure a single address, step number 1, configuring PAT. We need to define a standard access list permitting the addresses that should be translated. Step number 2, we have to establish dynamic source translation, specifying the access control list, exit interface and overload options. In step number 3, we have to identify the inside interface by giving the interface, then type and number, then IP NAT inside. In step number 4, we have to identify the outside interface by giving the commands interface, then its type and number and IP NAT outside. Once the PAT is configured, we can analyze the PAT between source and destination tables which are available on router 2. If we would like to verify the PAT translations, we can simply issue a command on a router 2 show space IP space NAT translation, which shows us the inside global address, how it links to inside local and outside global addresses. Port forwarding. Port forwarding is the act of forwarding a network port from one network to another. A packet sent to the public IP address and port of a router can be forwarded to a private IP address and port in inside network. Port forwarding is helpful in situations where servers have private addresses and are not reachable from the outside network. In this case, a SOHO small office home office router works as a port forwarding router. This is another example of SOHO small office home office example router. Configuring port forwarding with Inter-Network Operating System. In iOS, port forwarding is essentially a static NAT translation with a specified TCP or UDP port number. Configuring NAT and IPv version 6. NAT is a workaround for IPv4 addresses scarcity. IPv6 with a 128-bit addresses provides 340 undeclined addresses. Address space is not an issue for IPv6. IPv6 makes IPv4 public-private NAT unnecessary by design. However, IPv6 does implement a form of private addresses, and it is implemented differently than they are for IP version 4. IP version 6 unique local addresses or ULAs are designed to allow IPv6 communication within a local site. These unique local addresses are not meant to provide additional IPv6 address space. Unique local addresses have the prefix started with the hexadecimal number FC00::7, which results in a first hexstat range of FC00 to FDFF. Unique local addresses are also known as local IPv6 addresses, not to be confused with IPv6 local link addresses. NAT for IPv6. IPv6 also uses NAT, but in a much different context. In IPv6, NAT is used to provide transparent communication between IPv6 and IPv4. NAT64 is not intended to be a permanent solution. It is meant to be a transition mechanism. Network Address Translation Protocol translation NAT-PT was another NAT-based transition mechanism for IPv6, but is now depreciated by Internet Engineering Task Force. NAT64 is now recommended. This is how NAT for IPv6 works in a networking environment. A NAT64 router which is configured with the NAT64. Troubleshooting NAT. We can troubleshoot the NAT by using the show commands, such as in this example on router 2, we have given the command show IP NAT statistics, which basically gives all the statistics about the NAT. We can use also show IP NAT translation. In order to troubleshoot the NAT, we can use a debug command. In this example on router 2, we have issue a command debug space IP space NAT. Then the debugging will be started, and from where we can troubleshoot the problem. Summary of chapter number 5. In this chapter we have talked about what is NAT, how NAT is used to help alleviate the depreciation of the IPv4 addresses space. NAT conserves public address space and saves considerable administrative overhead in managing adds, moves and changes. NAT for IP version 4 including NAT characteristics, terminology and general operations. Different types of NAT including static NAT, dynamic NAT and NAT with overloading. Then we talked about the benefits and disadvantages of NAT, the configuration, verification and analysis of static NAT, dynamic NAT and NAT with overloading. Finally, we talked about port forwarding, which can be used to access an internal devices from the internet, troubleshooting NAT using the show and debug commands, and how NAT for IPv6 is used to translate between IPv6 addresses and IPv4 addresses. Thank you for watching.